So last time we had started section 7.4 about percent. We talked about the fact that percent means per hundred. We talked about the fact that it's actually very nice when we're working with percent problems to do them as proportions, because there's portions of them that are very nice to identify and fill in easily. And we are actually at the point where we're going to take a look at some mental math for percents. So there are some really nice ways that you can use mental math with percentages, some quick tricks, things like that. And that's what we're going to look at right now. For example, 15% of $42. So one way of dealing with this is that we could create a proportion. We'd have 15 over 100 and so forth. That's fine. There's nothing wrong with that. But I don't really think that most of that's mental math. It's not something you're going to do quickly in your head. You might say, well, I can just multiply it by 0.15. Again, true. Still, probably not in your head. Okay? So there's a really cool trick with 15% that I'd like to show you. So as you're aware, of course, 15% is the same as 10% and 5% added together. Right? Yes, it is. All right. Now, I do think that you can do 10% of $42 in your head. So, what is 10% of $42? 4.2, right? $4.20. You bet. Once you've done 10% of 42, you should now be able to do 5% of 42 very nicely. What would you do to get 5% once you've found 10%? Divide it in half. So what is half of 420? 2.1. And then you can add these together. What's 420 plus 210? 6.3 or $6.30. Okay. So here's the kicker about mental math, is that I can't see the math in your head. So you have to show me a little written work to sort of explain what you're doing in your head. Here's another kicker about mental math. You can only support so many mental math pieces at one time to get an answer. So for instance, 15%, that's actually 3 math problems you just did in your head, in theory. You found the 10%, you found the 5% to divide by 2, and then you added them. That's a 3-part problem. If you get any more than about 3 parts, it becomes something that's probably not going to be mental math. And even if it is mental math for you, it's probably not going to be mental math for the 6th grader that you're working with. Does that make sense? So be real careful at breaking things apart like this. Yes, it works really nicely, but only so much of that is truly going to work to do it all at one time in your head without writing some pieces down. Obviously, 20%, the same thing, works really nice. So if we have 20% of 280, again, it's easier to find 10% of 280, right? So what's 10% of 280? 28. You can either at that point add 28 to itself, or you could just double it, right? Multiply by 2. So what is 28 doubled? 56. Does it make sense? Okay. We'll do 5%. 5% is fine. We've already sort of done 5% by the previous work, right? So what would we do to find 5%? Yeah, we'll first find 10%. So 10% of 32 would be what? 320. And then Bailey was the one I heard actually saying it. Yeah, then we would divide by 2. So what is half of 320? 160. Right. Okay, so I'm going to show you a cool trick on D. It does not look like the previous problems. Okay? 25%, well, yes, you could break it apart into the 10% and find 10% twice and find the 5% and add it together. You're going to end up with quite a few steps, right? I'm going to have to find 10%, and then I'm going to have to double it, and I'm going to have to half it, and then I'm going to have to add at least 2 things together, depending on where I am in that process. 4 steps. We're not looking at mental math anymore when we've gotten to that many steps, okay? So 25% does not break down very nicely, but 25% has a super nice fraction that's associated with it. What's the fraction? 1/4, okay? So when I see 25%, it's far easier to think about this as the number 1/4. So finding 25% of 84 is the same thing as finding 1/4 of 84, which really just means division, right? What is 1/4 of 84? 21. That's 1 step, right? Not 4 steps. Michaela?
So is all of this enough work to like back our?
Absolutely.
Okay.
Mhm.
And so
Yeah.
is exactly what you're wanting us to?
Yep, something of that nature. Yours might look a little bit different in a little bit different places. Like, for instance, over here, when I did the 20% and I doubled it, you might actually write down 28 plus 28. Fabulous. I don't care, but some variations to it. But yeah, this is kind of what I'm looking for when you're trying to justify the work that you've done. Ariel?
Could we do the same thing that we did with the fraction on D for B because it was 20%? As an easy.
You could. 20% has the fraction of what? Do you know?
It's 1/5.
It's 1/5. So I think that dividing by 5 might be a little trickier with the number 280, but let's say you did the number 250. If you had the number 250, dividing by 5 would be very friendly. So yeah, it's probably a good method, but maybe with certain numbers, it makes more sense than others. Yeah. Okay, anything else? Okay, let's take a look at another example, moving on from the mental math. This is one of those type C kind of questions. Example 7. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? Emma?
The decrease would result in paying you.
Okay.
Does this be like a negative number so they don't give money?
A decrease would, right? Is that what you said? Yeah. So if it's something that actually decreased 150% in price, they would pay you the money to take the item from the store. Fun fact, I used to coupon. Homeland was a great place to coupon. And I actually did have something ring up negative at the register one time, but then they had to actually add something on because that wasn't going to happen, right? They weren't going to give me money to actually walk out the store with the stuff. So, yeah, that's the problem, right? We can't decrease more than 100% because 100% is all the value there is. But you can always increase, right? You just add it on. You just add on what you got. So, let's write some of that down. We cannot decrease more than 100%. Let me say it this way. Because a 100% decrease equals free. Okay, that's what a 100% decrease means. It's already free. So no decreasing more than 100%. But we can increase more than 100%. And let's just do an example. Let's say we had a $10 item. And if it increases 100%, yeah, somebody said it. It's a $20 value now, right? That's an increasing the percent. Well, I mean, we can just make it increase 50% more from the original value. The original value is $10. So what's 50% of $10? $5, right? So it's now $25. Okay, so you can always keep adding things on. There's just only so much you can take away before you end up at zero or a negative number. Any questions on that one? All right. I think my notes are actually clean and right at this point. Last semester was the first semester in this new book, and there were some adjustments in this section, so we'll see if my notes now match yours. The last part in this section is actually about interest. And our book used to have both compound interest and simple interest, which I think is totally fine, and then they decided to delete the compound interest, so congratulations. It's less information, right? Less to work with. Interest applications. So the part we're going to look at in this section for interest is about simple interest. So some definitional pieces first. Interest is the amount of money that you pay or you earn when you borrow or lend money. So paying would be like if you borrowed money from the bank for like a car or your student loans. The amount you pay back extra, that's interest. Earn is like if you put money in like a savings account, right? The money sits there, or you can think about it as like a mutual fund, or not really a mutual fund, more like a money market account or a CD, certificate of deposit. Any of those, any extra money they give you back that you didn't put in there, that's interest. Principal is the amount of money that you put in to that account or the amount of money you borrowed for that item. That's the principal. The interest rate is the percent used to determine interest. And then there are two simple interest formulas. They're highly related. The first one says A equals P plus PRT. The second one says A equals P times 1 plus RT. So notice if you just distribute the P through, you end up with the first one. Or if you take a look at the first equation and you factor the P out, you end up with the second equation. There's also something very friendly about the way that this one's written. So P is principal, right? PRT is interest. So if you take your principal and you add on the interest, that's the new amount that you've either paid for that product that you borrowed money for, or that you've earned that you now have, let's say it that way, in that bank account that you have. So you can kind of see the pieces of it in the first formula a little differently. So let's do an example. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. Let me go back real quick because I don't think I wrote it over here, but we should say it. The T is always time in years. So our problem that we're about to encounter gives us a number of months. We've got to figure out how many years that is first. And the R is the rate as a decimal. So if it's 4%, we have to write that 4% as 0.04. It has to be the decimal form. Okay, so coming back over here, so sorry. They borrowed $320,000, 13.5% interest, period of 18 months. How much interest will the company be charged? So if I'm only finding interest, that last equation on my slide is the one that we're going to work with. I equals PRT. Okay, so I, interest, is what I'm looking for. What is the principal, the P in our problem? Right, $320,000. What is the R, the interest rate? Yeah, it's 13.5%, and then written as a decimal, yeah, you would have 0.135. And the time says 18 months, which means the t value is actually 1.5 because it's the number of years. So grab a calculator because you're not doing that in your head. I'm not either. 320,000 times 0.135 times 1.5. What is it? $64,800. All right, that's the finance charge, if you will. All right, my last question I find to be very useful. Those of you who haven't taken the OGET yet, I've been told there's some similar things that show up, not necessarily content-wise, but in structure of thinking-wise as this particular problem. So let's take a look at it together. So it says, because of a recession, the value of a new house depreciated, that means it went down in value, 10% each year for 3 years in a row. Then, for the next 3 years, the economy began to recover and the value of the house increased by 10% per year. Question A says, did the value of the house increase or decrease after the 6 years? So, the first thing to understand is percentages cannot just be added or subtracted onto something. So it's not like I'm taking away 10%, I'm adding to 10% 3 times, and it all just is a wash. It's not a wash. It's not how percentages work. The problem with this is they don't give you any value for your house, right? So, do you know what we're going to do? We're going to make one up. That's right. We get to pick. And so we're just going to pick a nice value that's sort of still realistic, and I'm going to go with $100,000. Sound good to you? Okay. So we're going to start with a $100,000 house. So in year one, actually, let me start and write down my original value. My original value is $100,000. And in year one, it says that it's going to decrease by 10%. So if it's going down by 10%, how much of the percentage of value is it still worth? 90%, right? 100%, take away my 10%, it's worth 90%. And 90% as a decimal is what? 0.9. So what is 90% or 100,000 times 0.9? Y'all know it. What is it? Oh, you're a step ahead of me before that. 90,000 on this one, right? Yeah. It makes sense. It went down 10%, so it went down $10,000. Okay, so Annika's already on year two. On year two, the same thing happens. It goes down another 10%, but it's 10% of the $90,000 house because now it's worth $90,000. So it's going down 10%, but it's not going down $10,000, right? Because it's not worth $100,000, and that's 10% of $100,000. So if I take my $90,000 now and I multiply by 9, what do I get? That's the one you had, right? $81,000. One more year of the recession, year 3, $81,000, and it goes down by 10%. Do you have it? Go ahead, Ariel. 72,000. I'll tell you 900. Okay, good. 70,900. Okay, so obviously after those 3 years, it's, not good. Lost a bunch of money. The next 3 years, it's supposed to go up, right? So in year 4, I'm starting with my 72,900. Okay, so when it went down 10%, I took away 10%. If it goes up 10% of the 100%, I'm going to go up 0.1. So this should be 1.1 because that's 110%. So what is 72,900 times 1.1? It's not going to be 81,000.
80,109.
Yep, 80,000. 190? Cool. That's year 4. Now we're ready for year 5. Going to go up another 10%. So I've got my 80,190 times the 1.1. What's that one going to give me?
88,309.
Thank you. Okay, so Samantha says it's 88,209. Looking good. And year 6. Oops, almost said 5. We just did year 5. Year 6. We have our 88,209 going up by 1.1, right? 110%. What do we have?
97,029.9.
Okay, I'm going to go to a whole number and just do 30. Is that okay? All right. Did the value of the house increase or decrease over the past 6 years? Decreased, because it started at 100,000 and now it's worth 97. Now, the house owners are probably still very happy with the 97 because it went all the way down to 70 something, but overall it decreased. Part B is a very interesting question, because you can see how it really didn't matter the 100,000 I started with, right? Because I just looked at the beginning and the ending and I compared them. And the reality is that you could do a different value of house. You'd still get that it decreased. And you could still do Part B and you'll get the same answers as well. Part B asks us, by what percent did it increase or decrease over the 6-year period? Well, we know it was originally worth 100,000 and now it's worth 97,000. So what was the decrease in value? It was 100,000 and now it's 97,030, give or take. 2,000 what? 2,970. This is the value that we lost. Right? We lost almost $3,000 in the value of the house. And we can do a proportion like we were doing earlier when we did this on Monday. We're wanting to know what percent it went down. Well, we know what value it went down. It went down $2,970 on an originally $100,000 house. So yeah, if I didn't use a $100,000 house, I wouldn't have the $2,970. I'd have some other version of the value, but my proportion would still set up to be a ratio of those two values. And when I cross multiply, I get 100,000 x equals 2,970, 2 more zeros. What is 297,000 divided by 100,000? Yeah, 2.97%. And of course, it's a decrease, right? The house value decreased by about 3% in that 6-year time frame. And no matter what numbers you make up, you'll get the same answers. It's very cool. All right, go ahead and move into your groups. You have 4 group work problems from 7.4, and then we will do homework questions at the beginning of class next time for this section.